If tonight the Earth had only 24 hours left, what would you do? Would you call your family? Would you pray? Would you simply step outside and watch the sky, waiting for the end? Because that is what a single asteroid can mean. One rock, silent and ancient, moving faster than any bullet ever fired. It does not care who we are. It does not care what we've built. If it hits, it erases everything. Imagine it. The countdown begins. 24 hours until impact. The oceans would rise into walls of fire. Cities would burn in seconds. The very air would darken with dust for years. Humanity would become just another forgotten chapter, like the dinosaurs before us. Terrifying, isn't it? And yet, it hasn't happened. Not once in our lifetimes, not even in thousands of years of human memory. Why? Science gives us part of the answer.
Jupiter, the giant guardian of the solar system, pulls many of these killers away with its enormous gravity. Saturn helps too. Together, these gas giants act like cosmic shields. But here's the strange part. Even with their protection, Earth has faced countless near misses. Rocks that skimmed past our planet, close enough to end it all. But they didn't. So we must ask, is it just chance? Is it only gravity and numbers on a scientist's chart? Or is there something more? Ancient myths, whisper of gods who controlled the heavens, beings who chose when to strike and when to spare. Modern mystery suggests the same questions. Are we being watched, protected, or are we simply lucky, waiting for luck to run out? As you lie in the quiet tonight, feel the weight of that question. Because the truth is, Earth has been spared again and again.
Saved by something or someone we cannot fully explain. And that is the journey we take tonight, through the hard science of planetary defense. Through the haunting what-ifs of history, and into the shadows of mystery, where explanations end and imagination begins. So close your eyes, let the countdown echo in your mind. 24 hours to impact, except it never comes. The asteroid drifts away, and we are left to wonder, who or what keeps saving us? On the night of June 26, 2025, a family in McDonough, Georgia, awoke to a deafening crack. Something had torn through their roof, smashed a hole in the attic, ripped through an air duct, and finally landed on the living room floor. When the dust cleared, they discovered a rock, dark, heavy, otherworldly. It was no ordinary stone. It had fallen from space. NASA confirmed the object was a meteorite, a fragment billions of years old, older than Earth itself. It had traveled across unimaginable distances, only to end its journey in a suburban home. By sheer luck, no one was harmed. The meteorite sat quietly on the hardwood floor, a relic from the dawn of the solar system. To most people, it was a curiosity, a headline, a story to tell neighbors. To scientists, it was a reminder. Earth is always at risk. At any moment, a rock much larger than that Georgia meteorite could enter our skies. And if it did, we might not be so lucky. A fragile margin. The Georgia rock was small, no wider than a clenched fist, but imagine it 1,000 times bigger. Imagine an asteroid a kilometer across, plunging through the atmosphere at 20 kilometers per second. The heat of compression would ignite the sky. The impact would unleash energy equivalent to billions of nuclear weapons. Shock waves would flatten cities thousands of miles away. Dust and debris would climb into the stratosphere, blocking sunlight for years. This is not fantasy. It is history. 66 million years ago, a rock of this size ended the age of dinosaurs. The Chicxulub crater in Mexico tells the tale, a scar more than 150 kilometers wide, evidence of an impact that reset the course of life on Earth. Dinosaurs vanished, mammals rose. Humanity exists only because of that collision. And yet, in the millions of years since, Earth has avoided another extinction-scale strike. Smaller events, yes. Tunguska in 1908, when a blast flattened 80 million trees in Siberia. Chelyabinsk in 2013, when a 20-meter rock exploded in the sky over Russia, injuring more than 1,000 people. But nothing like Chicxulub, nothing close. So we must ask, why? Why, after billions of years of bombardment, does Earth enjoy this improbable quiet? The atmosphere as a filter. Part of the answer lies in our sky itself. Earth's atmosphere is more than air. It is armor. Every day the planet collides with tons of cosmic debris, grains of dust, pebbles, fragments of rock. Most disintegrate in brilliant flashes, burning as meteors long before they can touch the ground. Only the largest survive entry. The Georgia meteorite was one of the rare survivors. Most of its brothers and sisters never make it past the shield of air. Without an atmosphere, Earth would look more like the moon, its surface scarred by millions of craters, each a reminder of an impact that could not be stopped. But atmosphere alone cannot explain why we've avoided the truly massive ones. For that, we must look further outward. The cosmic guardian. Jupiter is more than a planet. It is a protector. With a mass over 300 times that of Earth, it bends the paths of comets and asteroids across the solar system. Many objects that might have wandered inward toward Earth are instead captured, redirected, or destroyed by Jupiter's gravity. The evidence is clear. In July 1994, humanity watched as comet Shoemaker-Levy 9 crashed into Jupiter. The comet had broken into fragments, each several kilometers across. As they struck the planet's atmosphere, explosions erupted. Scars larger than Earth itself burned into Jupiter's clouds. For a week, telescopes around the world recorded the spectacle. It was both beautiful and terrifying. Had those fragments continued inward, they could have crossed Earth's orbit. But Jupiter intercepted them. The giant planet absorbed the blows that might have been ours. Saturn plays a quieter role, but no less important. Its gravity, though weaker than Jupiter's, still shepherds asteroids, influencing orbital resonances that keep many dangerous bodies away from Earth. Together, Jupiter and Saturn form a kind of shield, not perfect, not absolute, but formidable. Imperfect protection. Yet the shield has holes. Tunguska, Chelyabinsk, Georgia. These events remind us that not everything is caught. Smaller rocks slip through, and larger ones could too. Astronomers estimate thousands of near-Earth objects larger than a kilometer still orbit the Sun. Most are harmless for now. But for now is not the same as forever. Jupiter's gravity can just as easily send an object toward Earth as away. It is a game of chance, a cosmic roulette. That we are here to tell stories means the wheel has spun in our favor again and again. But statistics remind us, eventually, luck runs out. Underscore, 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 underscore. The puzzle of probability. Here is where logic and mystery collide. The odds of a civilization surviving billions of years in a cosmic shooting gallery are not high, and yet humanity sits here,
fragile, unprepared, still alive? Is it simply probability stretched over time, or is something else at work? Astronomers prefer equations, orbital mechanics, gravitational resonance, impact frequency. They chart rocks, name them, calculate their paths decades ahead. But even with the math, the sense of unease remains. How many times has Earth been saved by a margin too thin for comfort? How many close calls go unnoticed, silent in the darkness, the whisper of the unknown? And so the question returns, is it only Jupiter, only physics? Or could there be another force, one we cannot measure, one we cannot prove? Some see divine providence, the hand of God diverting stones. Others imagine advanced civilizations, long vanished, who engineered protections we do not yet recognize. Still others point to the possibility that we are simply blind, unable to detect patterns that might one day reveal themselves. What is certain is this: the Georgia meteorite was not the first, and it will not be the last. Rocks will keep falling. Some will burn, some will strike, and some will miss us entirely. Whether by gravity, by chance, or by mystery, Earth has survived, a question left hanging. As you close your eyes tonight, remember the family in Georgia. Remember the hole in the roof, the rock on the living room floor, the reminder that space is not empty. It rains stone and fire, and yet here you are, breathing, listening, safe for another night. So ask yourself, why? Why did that meteor land harmlessly in a house and not as a mile-wide killer ending civilization? Why does Earth endure when the universe has no obligation to protect us? Is it the shield of Jupiter and Saturn? Is it the thin veil of our atmosphere? Or is it something beyond science, something unseen, choosing, for now, to let us live? Imagine, just for a moment, that all the safeguards failed. No gravitational shield from Jupiter. No gentle deflection by Saturn. No thin protection from our atmosphere strong enough to burn it away. What if a true giant, a mountain-sized asteroid, were to fall toward Earth tonight? This isn't the stuff of Hollywood alone. It has happened before. 66 million years ago, one such object struck near the Yucatan Peninsula. That was the day the dinosaurs disappeared, and mammals like us began their slow rise. The Earth still carries that scar, the Chicxulub crater, over 180 kilometers wide. Scientists studying that event estimate the asteroid was only about 10 kilometers across, just 10 kilometers, and yet, it reshaped life on an entire planet. Now, picture something similar today. First contact, the atmosphere burns. As the asteroid plummets through space and reaches Earth's upper atmosphere, it is moving at tens of kilometers per second. That's faster than a bullet, faster than anything we can imagine. Friction with the air would superheat its surface, turning night into day. For a brief moment, the falling body glows brighter than the sun. If you stood anywhere near its trajectory, you wouldn't see a rock. You would see a fireball stretching across the sky, leaving a long, glowing tail behind. Some observers would confuse it for a second sun rising where it doesn't belong. The sound would come later, a roar that shakes the bones. But the real terror isn't the light show, it's what comes after. The impact shockwave. When a kilometer-wide asteroid slams into Earth, the energy released is measured in millions of megatons of TNT. For comparison, the most powerful nuclear bomb ever detonated, the Tsar Bomba, released about 50 megatons. Imagine 10 million of those, all at once. The air itself would compress and explode outward. Windows would shatter hundreds of kilometers away. Entire cities could flatten just from the pressure wave. Even before the ground trembles,
The atmosphere has already delivered its punishment, and then the Earth itself responds. The ground trembles, the seas rise. At the point of impact, the Earth tears open. A crater forms, tens of kilometers across, molten rock spewing skyward. The shock travels through bedrock, triggering earthquakes that ripple outward like a bell being struck. If the asteroid were to fall into an ocean, which covers more than 2/3 of our planet, the water would not save us. It would rise. Tsunamis kilometers high would race outward, faster than jets. Coastlines on opposite sides of the world could be washed away within hours. Imagine the eastern seaboard of the United States gone in a single night. Imagine Japan, Indonesia, the Philippines erased beneath walls of water taller than their tallest buildings. The oceans would not forgive. The firestorm. But the most devastating part isn't just the wave or the quake. It's the sky. When an object of this size hits Earth, molten debris shoots upward, piercing the atmosphere, then falls back like a deadly rain. Each fragment burns as it re-enters, igniting forests, cities, grasslands. Scientists call this the global firestorm. Ash and smoke choke the skies. The temperature on the ground spikes to unbearable levels, hot winds rushing through continents. For hours, maybe days, Earth becomes a furnace. The long night, and then silence. After the fires, after the shock waves, after the tsunamis, comes the long darkness. Ash and soot suspended in the upper atmosphere block sunlight. Day turns to twilight. Photosynthesis halts. Crops fail. Animals starve. And humanity, with all our technology, with all our ambition, faces a winter colder than any ice age. Scientists call this impact winter. It could last months or even years. Temperatures fall by double digits. Growing seasons collapse. Even nations far from the blast zone are pulled into famine. Do you remember the eruption of Mount Tambora in 1815? It was a volcano, not an asteroid. Yet the ash it released into the stratosphere cooled the Earth so much that 1816 became the year without a summer. Crops failed in Europe and North America. Tens of thousands starved. That was just a volcano. A true impact would be far worse. Could we survive? It is a sobering thought. Could humanity, with its billions of people and fragile supply chains, survive a Chicxulub-scale event today? Some say yes. Underground bunkers, stockpiles of food, international cooperation. But others fear no. Civilization, so dependent on stability, might unravel. We live in an age of satellites and telescopes. We can see these cosmic bullets long before they arrive. Yet still many slip past undetected until they are already close. The Georgia meteor of June 2025, for example, was no bigger than a car, yet it punched through the atmosphere and pierced the roof of a home. It caused no fatalities, but it was a reminder. A whisper from the cosmos. You are still vulnerable. Now imagine that rock, scaled up 1,000 times. Would governments keep order? Would ordinary people remain calm? Or would panic spread faster than the shockwave itself? The cosmic coin toss. Here is the unsettling truth. We orbit in a shooting gallery. Earth is surrounded by debris left over from the birth of the solar system. Most of it is harmless dust. Some pieces are pebbles that burn up as shooting stars, but others are giants that wander. Their orbits cross ours from time to time, like wolves crossing the path of sheep. And yet, for all of recorded human history, we have been spared. Why? Some point to luck. Others to science, to the quiet guardianship of planets like Jupiter, whose immense gravity bends trajectories and swallows the most dangerous intruders.
Still others whisper about mysteries, unknown forces, unmeasured hands, something, or someone, watching over us. A pause before the next question. So here we are, safe for now. But the question lingers, quiet and sharp. What if the next one slips past Jupiter? What if it is already on its way, its path invisible in the dark between stars? Would we be ready? Or would we only realize too late as the sky lights up and the ground begins to tremble? Imagine for a moment that Jupiter and Saturn did not exist. Remove them from the solar system, wipe away their enormous gravity, their colossal presence in the night sky. What would happen? Would Earth still spin fragile and blue, untouched by catastrophe? Or would our world be nothing more than another cratered rock, scarred and lifeless like the moon? Astronomers often describe Jupiter as our shield, our cosmic guardian. But this is not poetry, it is physics. Jupiter's mass is so overwhelming that its gravity reaches across hundreds of millions of miles. When a wandering comet from the outer solar system drifts inward, it rarely passes Earth untouched. More often, it feels the pull of Jupiter first. Some are drawn in, swallowed whole. Others are hurled away, slingshotted into the darkness. In both cases, Earth is spared. Shoemaker Levy 9. Proof written in fire. The most dramatic example came in July 1994. Comet Shoemaker-Levy 9, once a single body, had been torn into fragments by Jupiter's gravity. Each fragment was still enormous, kilometers across. As the pieces crashed into Jupiter, telescopes on Earth watched explosions that dwarfed our planet. Black scars spread across Jupiter's clouds, large enough to swallow Earth many times over. For a week, humanity stared in awe. And in the quiet of observatories, some whispered the same thought. If Jupiter had not been there, if those fragments had wandered inward, Earth might have taken the blow. Civilization might not exist to tell the story. That event was no accident. It was the universe showing us what our protector can do. Saturn, the silent partner. Jupiter may steal the headlines, but Saturn plays its role too. Though smaller, it is still massive, 95 times the mass of Earth. Its gravitational influence shapes the asteroid belt, sculpting orbits through resonances. Where Saturn tugs, gaps appear. Where Saturn stabilizes, debris settles harmlessly. Together, Jupiter and Saturn form a pair of guardians. One catches, the other steadies. Both ensure that the inner solar system, where Earth and its neighbors circle the Sun, remains a place where life can flourish. The numbers behind the shield. Consider this. Without Jupiter and Saturn, simulations show that the rate of asteroid impacts on Earth would be far higher. Some scientists argue Earth might never have sustained complex life at all. Every few million years, an extinction-level impact could erase progress, wiping the evolutionary slate clean. Instead, while Earth has scars, they are fewer than expected. Life had time to rise, diversify, and evolve into intelligence. Humanity owes its existence not just to evolution, but to orbital mechanics, to the silent work of giants we can barely comprehend. An imperfect defense. And yet, the shield is not flawless. Tunguska, Chelyabinsk, Georgia, 2025. Small rocks still slip through. Even Jupiter itself can sometimes redirect danger toward us, not away. The cosmos does not give guarantees. This duality, protection and risk, makes the story richer. Jupiter saves us, but it could also betray us. Saturn calms orbits, but it cannot prevent chaos forever. We live in balance, never absolute safety. A question of design. Here is where mystery returns. Why are the giants placed where they are? Why is Jupiter not closer or farther or absent altogether?
If the architecture of the solar system were different, life on Earth might never have emerged. Scientists call this the anthropic principle, the idea that we observe the universe the way it is, because only in such a universe could observers like us exist. But to many, it feels like more than coincidence. Was it chance that Jupiter and Saturn formed as guardians? Or is it evidence of a deeper order, perhaps even design? Ancient peoples looked at Jupiter, the bright wandering star, and called it the king of the gods. Saturn, slower and dimmer, became the god of time and fate. They sensed something about these worlds, that they were not just lights in the sky, but powers shaping destiny. And now, with telescopes and physics, we find they were not wrong. A gate that swings both ways. As you lie in the quiet tonight, picture Earth as a fragile village at the edge of a dark forest. Beyond the fields roam predators, comets, asteroids, icy wanderers from the void. At the village gate stand two enormous guards. One bears storms swirling for centuries. The other wears rings that glitter like armor. Most of the time, they turn away the threats before they reach us. Sometimes, one slips past. But still, we are here, breathing, alive, because the gatekeepers remain at their posts. And the question lingers. Did we simply get lucky? Or was the gate built for us? Imagine for a moment the vast emptiness of our solar system. Between the planets, trillions of fragments, asteroids, comets, wandering debris drift in darkness. Many of them follow predictable orbits, quiet companions to the planets. Others move chaotically, pulled and pushed by gravity until one day their path crosses dangerously close to Earth. Now, here is where something remarkable happens. Again and again, across billions of years, two titans of the solar system have acted as silent guardians, Jupiter and Saturn. These gas giants, massive beyond comprehension, shape the fate of wandering rocks long before they reach our fragile world. Jupiter alone holds more than twice the mass of all the other planets combined. Its gravity is a cosmic anchor, extending influence millions of kilometers in every direction. Saturn, though lighter, still dwarfs Earth more than 90 times over. Together they form a gravitational barrier, a pair of watchful giants standing between Earth and destruction. Astronomers have long debated how much protection Jupiter provides. Some studies show that its gravitational pull draws comets inward, accelerating them toward the Sun, and occasionally toward Earth. Others reveal the opposite. Jupiter's immense mass slingshots many of these objects out of the solar system entirely, banishing them before they can threaten us. The truth is both. Jupiter is not only a shield, but also a sword, capable of saving or dooming us, depending on the geometry of a cosmic encounter. One of the most famous demonstrations of this dual role occurred in 1994, when comet Shoemaker-Levy 9 smashed into Jupiter itself. The comet had been torn apart by the giant's gravity years earlier, fragmented into more than 20 separate pieces. When those fragments plunged into Jupiter's atmosphere, telescopes on Earth captured fireballs larger than our entire planet. For days, scars lingered on Jupiter's cloud tops, bruises from a cosmic beating. Had Jupiter not been there, those fragments might have continued inward. Their trajectories could have intersected with Mars or Earth. Instead, the gas giant absorbed the blows, taking damage on our behalf. Astronomers watching from Earth couldn't help but shiver. It was as though Jupiter had stepped in front of a bullet meant for us. But the question remains, was that mere chance or part of a larger pattern? Let us pause. Think of how many near-Earth asteroids are tracked today, Thousands, their orbits cataloged by NASA's Planetary Defense Coordination Office. Now imagine all the untracked debris, the dark fragments too small to reflect light, the icy comets still hidden in the far reaches of the Oort cloud. If even a fraction of those were nudged toward the inner solar system without Jupiter's interference, how many more would threaten Earth? How many times have we survived not because of our own strength, but because of a silent intervention from millions of kilometers away? Numbers offer some comfort. Simulations suggest that Jupiter may have reduced the number of long-period comets striking Earth by a factor of several hundred. Without Jupiter, the probability of catastrophic impacts could be orders of magnitude higher. Life on Earth, fragile and easily disrupted, might never have had the chance to evolve to this point. But science only explains the mechanism. Gravity, mass, momentum, terms that fit neatly into equations. What science cannot answer is the deeper question. Why does the solar system happen to be arranged this way? Why does a planet of Jupiter's size sit exactly where it can intercept so many incoming threats? Why do Saturn's resonances further shape and stabilize belts of asteroids, sometimes steering danger away from Earth's orbit? Is it coincidence, or is there something else, something we cannot yet explain, guiding the design of this celestial shield? To understand the scale of Jupiter and Saturn's guardianship, we must turn to real examples, moments when their influence was written across the sky. Take Comet Encke, a frequent visitor to the inner solar system. Its path crosses close to Earth every few years. For centuries, gravitational nudges from Jupiter have altered its orbit, gradually pulling it into a stable pattern. Without Jupiter, Encke's fragments might scatter unpredictably, some eventually colliding with Earth. Instead, the comet follows a route that is dangerous but predictable. Predictability is safety. We know when and where to look, when to raise our telescopes, when to prepare. Or consider the countless asteroids of the main belt, lying between Mars and Jupiter. They might seem harmless, floating far from Earth. Yet Jupiter's gravity sculpts this belt with precision. Where orbital resonances occur, points where an asteroid's orbit would line up with Jupiter's repeated tugs, empty gaps form. These are called Kirkwood gaps, voids carved by the giant's unseen hand. By clearing these regions, Jupiter prevents countless rocks from being nudged into Earth-crossing orbits. And then there are the near misses. In 2022, asteroid 7482, 1994 PC1, nearly a kilometer wide, passed within 2 million kilometers of Earth. Astronomers noted that its trajectory, centuries earlier, had been influenced by gravitational interactions with both Jupiter and Saturn. Had those interactions been slightly different, the rock might have struck us instead of gliding by. We owe that narrow escape not to luck alone, but to a complex dance of planetary forces. Statistically, the effect is staggering. Simulations conducted by planetary scientists suggest that without Jupiter's gravitational shield, Earth would experience large impacts, asteroids several kilometers across, 10 times more frequently. Some estimates go further, suggesting that Earth's surface might resemble the Moon's, covered in scars from unrelenting bombardment. The difference between a thriving biosphere and a sterile wasteland may lie in the orbit of one giant planet. And yet, here lies the mystery, because Jupiter's gravity can also betray us. In some scenarios, the giant does not shield but redirects. A comet grazing its influence might be hurled inward, its path bent toward Earth rather than away. Jupiter is not a benevolent god, but a neutral force, sometimes protector, sometimes executioner.
The very mass that saves us could also doom us. So why, across the history of life, has it so often saved? Why do the catastrophic strikes come rarely enough to allow complex creatures, dinosaurs, mammals, humans, to rise? Was it nothing more than probability stretched across deep time? Or is there something more intentional behind the pattern? Ancient peoples saw Jupiter and Saturn not as planets but as gods. Jupiter was Zeus, king of the heavens, wielder of lightning, ruler of fate. Saturn was Cronus, the keeper of time, the devourer of chaos. Even without telescopes, they intuited something about these wandering stars, that their presence was more than decoration in the sky, that they shaped destiny. Today, we dress those intuitions in scientific clothing: gravity, orbital mechanics, N-body simulations. But the awe remains the same. When you watch a meteor streak across the night sky and know it burned up harmlessly, you are seeing the end of a journey shaped by forces far beyond your control. Forces that might have nudged it millions of years ago, long before humans ever walked the earth. Forces that, again and again, turn death aside and leave us here to wonder. Coincidence, gravity, or design? Which answer do you find yourself drifting toward? If the story ended with equations, perhaps it would feel settled. Jupiter is massive, Saturn adds balance, their orbits shape the flow of comets and asteroids. Case closed. But the more closely we study, the less simple it becomes. Computer models run by planetary scientists show conflicting outcomes. In some, Jupiter is a net protector, dramatically reducing the number of catastrophic impacts on Earth. In others, it increases the risk by flinging objects inward. The truth seems to lie somewhere in between. Jupiter both saves and threatens us, depending on chance encounters written into the fabric of time. And yet Earth remains here, scarred, yes, but alive. Billions of years, countless near misses, only a handful of true cataclysms. Enough to shape evolution, but not enough to erase it entirely. Enough to kill the dinosaurs, but not to extinguish life. Enough to remind us of fragility, yet still leave us standing. How many times, one wonders, did a fragment's path bend by only a fraction of a degree, just enough to miss Earth? How many times did Saturn's resonance shift a rock into a harmless orbit, rather than an Earth-crossing one? When we look at probability alone, survival feels improbable. When we look at history, it feels inevitable. That tension is the heart of the mystery. Some argue that this is proof of the anthropic principle. We are here asking questions only because conditions allowed us to exist. If the shield had failed, if impacts had come too often, intelligent life would never have emerged to notice. In this view, our survival is not extraordinary. It is simply the only possible outcome. We could not exist in a universe where we had already been destroyed. But others sense something deeper. They see not randomness, but rhythm. They ask, why is Jupiter so perfectly placed? Why does Saturn's orbit create patterns of protection instead of chaos? Why did these giants form at all, when planetary systems elsewhere in the galaxy often lack such guardians? We do not yet know. Perhaps we never will. For now, what we can say is this: every fireball that burns in the night sky and never touches the ground is part of a story that began long before. Each harmless streak of light is evidence of unseen battles fought in silence. Gravitational wars waged between titans, with Earth as the fragile prize. So the next time you look up and see a meteor pass overhead, consider the journey it has taken. Consider the forces that shaped its path. Consider how close it might have come and how easily the story could have ended differently.
And then ask yourself the question that lingers like a whisper in the dark. Are we alive because of chance, because of gravity, or because something or someone wants us to be? What if gravity alone is not the full story? The narrative we have followed so far, giant planets bending trajectories, probabilities shaping survival, feels solid, logical. Yet woven between the lines of astronomy are threads of something stranger. Threads that hint at patterns beyond random chance. Consider the silence of space. For billions of years, objects have reigned through the solar system, colliding, fragmenting, reshaping worlds. Mars bears scars of ancient strikes. Mercury is pockmarked from pole to pole. Even Earth's own moon, our constant companion, is a battered archive of cosmic violence. And yet Earth itself, small and fragile, has endured. Catastrophes have struck, yes, but rarely the kind that end everything. We circle a star in a thin orbit where life is possible. We are shielded by giants. And time after time, rocks the size of mountains have passed by instead of hitting. Coincidence? Or something more? Some researchers dare to suggest patterns too consistent to ignore. They point to near-miss events, asteroids that arrive with precision, passing between Earth and the Moon, missing by margins so slim that, had their trajectory shifted by a few hundred kilometers, history itself would have ended. Why so many close calls? Why survival again and again, across epochs? One line of speculation proposes intervention, a force unseen, operating on scales we cannot yet comprehend, nudging paths of stone and ice by the tiniest degrees, a force that wants Earth to continue, a force that ensures we remain here long enough to ask questions about it. This hypothesis, of course, sits outside science. No peer-reviewed paper concludes that something out there saves us. But in the quiet spaces of late-night conversations, even scientists admit a whisper of unease. Could intelligence exist that far surpasses ours? Intelligence capable of manipulating gravity itself? To shift a 10-kilometer-wide asteroid requires unimaginable energy. Our current technology cannot even push a city-sized rock by a fraction of a degree without enormous effort. Yet cosmic forces, unknown, invisible, might manage it with elegance beyond our understanding. If so, who or what are they? Ancient myths across cultures speak of sky gods, protectors, beings who hurled fire from the heavens or shielded humanity from it. In Sumerian tablets, celestial battles raged. In Greek epics, Jupiter, Zeus, wielded thunderbolts to protect or punish. In Hindu texts, deities guarded the earth from cosmic demons. Were these merely stories or echoes of something real? Memories of times when the sky itself seemed to act with purpose. The modern UFO community sometimes weaves these threads together. They argue that what ancients described as gods may have been advanced visitors, watching, guiding, occasionally interfering. Not always to save, not always to punish, but always to remind us we are not alone. Skeptics dismiss this as fantasy. Yet even skepticism cannot erase the questions. Why is Earth's history balanced so delicately between destruction and survival? Why has life endured when statistics suggest it should not have? Perhaps it is chance. Perhaps it is gravity. Or perhaps it is something more. Something patient, deliberate, and watching still. If an unseen intelligence truly touched the paths of asteroids, how would it do so? Our imagination falters when faced with such scales. A rock 10 kilometers wide weighs billions of tons. To move it even a fraction of a degree requires energy beyond our current comprehension. And yet, the universe holds forces vast enough to make such feats possible. Gravity, magnetism, subtle nudges applied not in moments, but across centuries. Some scientists speculate that if advanced civilizations exist, they would not need brute force. They would use patience. A carefully timed encounter, a probe releasing a small burst of energy, a gravitational assist from another object, could redirect an asteroid's path over millions of kilometers. To us, it would look like coincidence. To them, it would be design. Think of billiards. A skilled player doesn't smash the cue ball at random. They strike with precision, setting up the next move, guiding motion long before the final shot. If cosmic guardians exist, perhaps they too play across tables of unimaginable size, striking once to guide a rock's fate centuries later. But then comes the deeper question: why? Why would any intelligence care whether Earth survives or not? The motives of the invisible. Some suggest benevolence. Perhaps we are being nurtured, like seedlings in a vast cosmic garden. Each near miss, each avoided catastrophe, ensures our species has more time to grow, to learn, to become something greater. Others whisper of selfish motives. Maybe Earth is valuable, not for us, but for resources, biology, or as part of a larger plan. Protecting us may be less about kindness and more about preserving an experiment. And then there is the darker possibility. Perhaps survival itself is a test. If we endure, if we rise, we might someday meet those who shaped our chances. If we fail, the silence continues, and no one will mourn. Signs in the silence. Have we seen hints of such influence? Some point to the uncanny timing of impacts. Tunguska in 1908 flattened a remote forest in Siberia, but spared populated cities. Chelyabinsk in 2013 injured many, but killed none. Georgia in 2025 tore through a roof but harmed no one. Over and over, disasters skirt true annihilation. Coincidence, yes. But also patterns. Patterns that spark whispers of intervention. If these events were deliberate, carefully allowed, carefully limited, they serve as reminders without ending the story. Gentle warnings rather than final blows. The universe tapping on our shoulder saying, "Remember your fragility." The shadow of doubt. Of course, all this remains speculation. Astronomers return to gravity, equations, and probability. They insist that nothing more is needed to explain survival. And perhaps they are right. But as you listen tonight, drifting towards sleep, ask yourself, what explanation feels more unsettling? That we live by pure chance in a universe indifferent to us? Or that something immense, unseen, and intelligent has already noticed us and chosen, again and again, to let us continue? One story leaves us small and alone. The other leaves us small, but watched. Which is the greater comfort? Which is the greater fear? Between wonder and sleep. And so the question lingers in the quiet. Who holds the cue stick in this cosmic game? Who bends the stones before they fall? And if they are there, if they have saved us, how long will their patience last? Close your eyes. Picture the dark beyond the stars, vast and silent. Somewhere out there, perhaps, hands are already at work, shaping the next near miss, ensuring we wake tomorrow to ask again. Was it chance? Was it gravity? Or was it something far stranger, whispering through the void? Imagine the universe as a forest at night. The trees stretch endlessly, their shadows tangled, their silence heavy. You stand among them, holding your breath. Somewhere out there, unseen eyes may already be watching. This is the metaphor that scientists and philosophers call the dark forest hypothesis. It is one of the most unsettling explanations for the Fermi paradox, the question first asked in the 1950s. If intelligent life is common, why don't we see it? Why is the universe so silent? The answer in this view is chilling. Everyone is hiding. In a forest filled with hunters, survival belongs to the quiet. To shout, to reveal your location, is to invite death. And so civilizations, if they exist, may choose silence, not out of shyness, but out of fear. They do not broadcast, they do not reveal, they wait in shadows, hoping not to be found. Now consider Earth. For a century, we have been leaking signals into space: radio, television, radar, digital pulses. To us, they seem weak, fading into the stars. But to a civilization more advanced, they may shine like a beacon in the night. Our presence is no secret. We have already spoken, whether we intended to or not. And yet, no answer has come. No message, no signal, no undeniable proof. Just silence. Is the silence proof that no one is out there? Or proof that everyone out there is hiding? Survival through silence. The dark forest hypothesis proposes a brutal logic. Every civilization wants to survive, but it cannot know the intentions of others. Perhaps they are peaceful, perhaps they are predators. The safest assumption is the worst, that any other intelligence could destroy you if given the chance. So what do? You stay quiet, you watch. And if you detect another voice, you face a terrible choice: hide or strike first. This is the paradox we face. If civilizations follow this logic, the universe would look exactly as it does: vast, silent, filled with stars, yet devoid of voices. Not because no one is there, but because everyone is waiting. The link to our story. What does this mean for Earth's strange history of near misses and survivals? If others are hiding, why would anyone intervene to help us? Wouldn't protection itself be a kind of revelation? Unless the protection is not intervention at all, but coincidence disguised as mercy. Unless Jupiter's shield and Saturn's balance are the only guardians we have, and the silence of the forest is deeper than we imagine. Or perhaps if intervention exists, it is not benevolence, but strategy. A hidden hand that saves us not because we are special, but because we are useful. An experiment, a pawn, a seedling preserved until the right time. Which is more comforting? To believe we are alone in a dangerous forest, or to believe someone is out there watching us, deciding when to let us live? If the universe is a dark forest, then every star is a tree, and every planet a shadow beneath its branches. Somewhere unseen hunters may wait. Somewhere fires may burn quietly, hidden from view. The thought is unsettling because it changes how we see survival. We are used to thinking of progress as expansion, sending signals, exploring, colonizing. But in a dark forest, progress is silence. To live is to hide. To reveal yourself is to risk annihilation. Earth's shout. And yet, Earth has never been silent. From the moment we lit our first fires, we glowed faintly in the night. From the moment Marconi's first radio waves leapt into the sky, we began to shout. For more than a century, our signals have rushed outward, expanding at the speed of light, announcing, "We are here." If the forest is truly dark, then our voice is reckless. We are the child who calls into the shadows, unaware that predators may be listening. And here is where the unease deepens. What if the near misses, the asteroids that pass close but do not strike, are not protection, but observation? What if each one is a test, a probe, a way of measuring how loudly we shout, how carelessly we move? Not guardianship, but surveillance. A game of waiting. The dark forest hypothesis offers two terrifying possibilities. The first, that no one hears us because no one is left. Civilizations rise, discover fire, discover radio, and then destroy themselves. The forest is silent because the hunters are gone. The second, that someone hears us but chooses not to answer. Perhaps they fear us. Perhaps they study us. Perhaps they are waiting for us to reveal more, our strength, our weakness, our intentions. In either case, the silence is not comforting. It is heavy, deliberate, watchful. How should we respond? Some argue we should stop transmitting altogether. They call it cosmic quarantine. Listen, but do not shout. Watch, but do not reveal. Projects like Metai, messaging to extraterrestrial intelligence, spark controversy because they break this rule, sending deliberate messages into the dark. Critics say it is like striking a match in the forest, a flame that may draw hunters near. Others argue the opposite. If everyone hides, no one connects. Someone must take the risk. Perhaps silence is not survival, but stagnation. Perhaps shouting is the only way to find others before the darkness consumes us alone. Where do you stand? In your heart, as you drift into sleep, do you prefer a safe silence or a dangerous chance at contact? Tying back to the stones. And what of the asteroids? What of the near misses, the cosmic bullets that graze but do not kill? Are they chance? Are they gravity? Or are they subtle signs? A reminder that in this forest, even rocks can be tools. Some believe that if a civilization wanted to end us, they would not need warships or weapons. They could nudge a single asteroid. A stone from the sky is more powerful than any missile we could launch. And so the question turns again, are we spared because no one cares, or because someone does, and waits? A final whisper, before sleep. The dark forest hypothesis is not comforting. It is not meant to be. It reminds us that the silence we hear may not be empty, that survival may depend not on discovery, but on discretion, that the next voice we hear may not be friendly. As you close your eyes tonight, imagine the forest stretching outward, endless and dark. Imagine Earth as a campfire burning softly, its light reaching out into the trees. And ask yourself, is someone watching from the shadows? If they are, what do they see? If they are, what do they wait for? And if they are, when will they step into the light? Until then, the silence continues. And in that silence, the question echoes, are we truly alone or only unseen? The silence of the cosmos forces us to ask a terrible question. If life can arise, why has it not endured? If civilizations bloom like flowers among the stars, why do we see only darkness, only quiet? One possible answer is the Great Filter. The term was first proposed by economist Robin Hanson in the 1990s, but the idea is older, woven into philosophy and science alike. The Great Filter is the possibility that somewhere along the path from simple chemistry to galaxy-spanning intelligence lies a barrier so difficult, so destructive, that almost nothing can cross it. Life may begin often. Microbes may crawl across countless worlds, but to grow beyond a certain point, to rise, to flourish, to endure, requires passing the filter, and most fail. The steps toward civilization. To see the filter clearly, imagine the journey of life as a staircase. 1. Chemistry into biology. Simple molecules assemble into self-replicating forms. 2. Simple life. Microbes, cells, organisms that endure. 3. Complex life. Multicellular beings, evolution of variety and scale. 4. Intelligence. Brains, tools, societies. 5. Technology. Fire, agriculture, industry, energy. 6. Survival. Mastery of threats, both cosmic and self-made. 7. Expansion. Spreading to other worlds, ensuring permanence. At which step does the filter stand? Perhaps it is near the beginning. Perhaps the leap from chemistry to life is so improbable that Earth itself may be unique across billions of stars. If so, we are rare, precious beyond imagination. Or perhaps the filter lies ahead. Perhaps many worlds produce life, even intelligence, even technology, but none survive their own power. They invent weapons faster than wisdom. They consume resources faster than renewal. They collapse, vanish, leave only ruins for no one to find. Which is worse, to be utterly alone, or to know that our end is almost certain? History written in craters on Earth. The scars of past extinctions whisper warnings. The Permian extinction, 252 million years ago, erased nearly 90% of marine species. The Chicxulub impact ended the age of dinosaurs. Volcanic winters, ice ages, supernovae and distant skies, all reminders that survival is fragile. And yet life returned. Again and again the pattern repeated. Destruction, then rebirth. Does this mean Earth has passed the filter already, enduring blows that would end other worlds? Or does it mean our filter still waits ahead, silent, inevitable? Cosmic loneliness. Astronomers search for signs of advanced civilizations, radio signals, megastructures, chemical signatures. They find nothing. Stars burn, planets orbit, but no great empires rise to announce themselves. The sky remains indifferent. The filter may be why. Civilizations may light fires briefly, then extinguish themselves before their voices reach us. The forest is not empty. It is a graveyard. As you drift towards sleep, consider the unsettling symmetry. Life is common enough to begin, but rare enough to survive. We may walk the same path others once did, blind to the cliff ahead. And the question that lingers like a shadow: are we already past the great filter, or standing just before it? If the great filter lies in our past, then humanity is extraordinary. We are the rare exception, the improbable survivors, standing alone in a quiet universe. But if the great filter lies ahead, then we are fragile, teetering at the edge of fate. Which possibility feels more true to you? The shadows of today. Look around our world tonight. We see progress, electric cities glowing, rockets climbing into the sky, computers weaving knowledge at the speed of thought. But woven into that progress are seeds of danger. Nuclear weapons, still poised decades after their invention. Climate change, heating oceans and skies beyond stability. Biological threats, from pandemics, natural or engineered. Artificial intelligence, powerful yet untested. Each of these could be our filter. Not meteors from the sky, not eruptions from Earth, but choices made by our own hands. Civilizations may not die from external blows alone. They may stumble on their own inventions, failing to balance wisdom with power. Are we clever enough to escape the trap, or are we another spark soon to fade? The cosmic timescale. Consider how brief our story is. Agriculture, 10,000 years. Industry, 200 years. Spaceflight, 60 years. Against the scale of billions, we are newborns. If civilizations must survive for millions of years to spread among the stars, then the odds are harsh. Most will vanish before they take root. The silence of the sky may not mean no one has tried. It may mean no one has lasted. So when we search, perhaps what we are really seeing is failure written across galaxies, ruins too far to detect, voices too faint to hear. A cosmic pattern of beginnings without continuations. Earth at the crossroads. Tonight, humanity stands at a choice. We can treat the filter as destiny, accept collapse as inevitable, or we can treat it as warning, bending our path to avoid it. The science is clear. Cooperation matters. Survival demands global vision. The threats we face are no longer local, they are planetary. An asteroid does not strike one nation. A climate does not stop at a border. A virus does not need a passport. If we continue divided, the filter may claim us. If we unite, perhaps we pass through. But unity is fragile, and the clock ticks louder each year. The hints of mystery. Here is where whispers of the unknown return. If some force, natural or otherwise, has spared us from cosmic blows, if Jupiter shields us, if mysterious hands nudge rocks away, could it be that survival itself is part of a larger pattern? That intelligence is meant to endure, but only if it learns humility. Perhaps the filter is not only destruction, but transformation. Civilizations that survive may change so radically, merging with machines, ascending dimensions, altering their very essence, that they no longer resemble what came before. To us, they look like silence. In truth, they may be everywhere, invisible because they are no longer what we expect. And if that is so, then what is humanity becoming? A mirror for the sleeper. As you rest, let this thought settle. The great filter is not only a theory of astronomy, but a mirror held up to us. It asks, will we endure or will we join the silence? Perhaps tonight, in another world, another species once asked the same. They too lit fires. They too built machines. They too wondered at the stars. And then they ended. Will we? The filter is not a prophecy. It is a question, one that waits for us to answer not with words but with survival. So close your eyes. Picture Earth, small and bright against the black. Picture the paths ahead, one leading to silence, one to survival. And know that the choice, fragile and uncertain, lies not in the stars, but in us. In 1950, on an ordinary afternoon at Los Alamos National Laboratory, physicist Enrico Fermi sat down to lunch with colleagues. They joked about cartoon aliens, about reports of flying saucers, about rockets climbing into the sky. Then Fermi grew quiet. He asked a question so simple, so devastating, that it echoes across decades. Where is everybody? The question was not about Earth. It was about the universe. By then, astronomers knew the Milky Way alone held hundreds of billions of stars. Many of those stars were older than the Sun, giving them more time to develop planets, life, intelligence. If civilizations arose often, Fermi reasoned, then the galaxy should already be teeming with them. Some should be ahead of us by thousands or millions of years. So where are they? Why do we not see their ships? Why do we not hear their voices? Why, when we listen, is the cosmos so very silent? The scale of expectation. Pause here. Imagine standing on a beach staring at the ocean. Billions of waves. Endless horizon. Now imagine throwing a single pebble into that water and hoping it makes no sound, no ripple. Impossible, isn't it? That is what the silence of the stars feels like. The universe is the ocean. Civilizations, if they exist, are the pebbles. We expect ripples. We expect signs, radio signals, light beacons, enormous structures harvesting energy from stars. But instead, we see stillness. Astronomers call this the Fermi paradox. A paradox not because the math is wrong, the math is overwhelming, but because reality refuses to match it. The search that finds nothing. For more than half a century, we have searched. The SETI program, Search for Extraterrestrial Intelligence, has pointed radio telescopes at the sky, listening for narrow-band signals, artificial fingerprints in the cosmic noise. They have listened to stars near and far, scanned thousands of frequencies, recorded terabytes of data. The result? Nothing. No structured signal, no repeating code, only the natural hiss of the cosmos. Astronomers also search in light. They look for Dyson spheres,
vast megastructures that advanced civilizations might build around stars to capture their energy. They search for infrared excesses, strange dimming, patterns no natural process could explain. Again, nothing. They examine atmospheres of exoplanets, looking for biosignatures, oxygen, methane, complex mixtures that scream of life. They find promising worlds, yes, but no certainty. And so the silence deepens. Explanations. That unsettle many explanations have been offered for the paradox. None are comforting. 1. We are alone. Life itself is so rare that Earth may be unique. 2. They are hiding. As in the dark forest hypothesis, civilizations conceal themselves for survival. 3. They are gone. The great filter erased them before they could expand. 4. We cannot recognize them. Their technology, their forms, their signals are so advanced that we mistake them for background noise. 5. They are too far. The galaxy is vast, and light takes time. Their voices may not have reached us yet, or ours not reach them. Which explanation feels most likely? Which feels most terrifying? The weight of silence. Silence is not empty. Silence carries weight. When you wait for a reply that never comes, the absence itself becomes an answer. Perhaps civilizations flare briefly, like candles, then vanish. Perhaps we are latecomers to a galaxy already emptied. Or perhaps we are early, standing in a forest where no other fire has yet been lit. Fermi's question is not just about aliens, it is about us. If the universe is empty, what does that say about life? If the universe is full, why has no one reached us? Either way, the implications are profound. A cosmic mirror. The paradox forces us to look inward. Maybe we do not hear others because we're not listening in the right way. Or maybe we do not hear others because soon there will be no one to hear us. The silence becomes a mirror. It reflects our hopes, our fears, our future. Will humanity endure long enough to break the silence? Or will we too vanish into it? As you drift toward rest, let Fermi's whisper linger. Where is everybody? Not shouted, not answered. Only asked, again and again, across the decades, across the stars. Fermi's question does not fade. It grows louder the more we learn. Each discovery of a new planet, each survey of distant stars, each confirmation that conditions for life exist elsewhere, only sharpens the silence. If the galaxy is fertile, why does it feel barren? The numbers that demand voices. Let us begin with numbers. The Milky Way contains at least 400 billion stars. Current estimates suggest that 1 in 5 of those may host Earth-like planets within habitable zones. That means tens of billions of potential Earths. Even if life began on only a fraction, and intelligence on only a fraction of those, we would expect thousands, millions of civilizations across time. Some older, some younger, some just beginning, some far ahead. And yet, when we tune our instruments, we hear nothing. When we scan the skies, we see only stars and silence. It is like walking into a stadium that should be roaring with voices, only to find empty seats, echoing corridors, and wind. Are we deaf, or is the universe quiet? One answer is humbling. Perhaps we are not good listeners. Our tools are primitive, our methods narrow. We search for signals like ours, radio waves, light pulses, megastructures. But what if intelligence communicates in ways we cannot imagine? Quantum entanglement, dimensions beyond ours, methods invisible to us. A dog in a library hears only noise. A human sees words. Perhaps we are still the dog, ears pricked, missing the message. Another answer is darker. Maybe there are no messages to hear. Maybe the voices burned out long before we arrived.
Civilizations may be rare flickers rising and falling within narrow windows of time. We do not overlap with them. We are alone not because they never existed, but because they no longer do. The possibility of watchers. And yet, another unsettling possibility remains. Perhaps the silence is not absence, but choice. If the dark forest is real, then watchers may already know of us. They may study without contact, observe without reply. To them, our radio waves are not greetings, but warnings, evidence of a civilization too noisy, too reckless. If so, then the silence is deliberate. It is the sound of decision. They choose not to answer, not to reveal. Would you prefer that no one is out there, or that someone is, watching, waiting, silent? A lesson in humility. Fermi's paradox humbles us. It tells us that our assumptions about life, about destiny, about inevitability, may be wrong. It forces us to accept that intelligence may not be the natural end of evolution. It may be rare, it may be fragile, it may be doomed. And so the paradox is not only about the stars. It is about Earth. It is about us. The whisper before sleep. As you rest tonight, let the silence of the universe settle over you. Think of the billions of stars, each a sun, each with worlds circling. Think of the ages that have passed, the voices that may have risen and fallen. Think of Fermi in 1950, pausing at lunch, asking the question that still pierces us. Where is everybody? The whisper carries through time, unanswered. Perhaps it always will. Or perhaps someday when we least expect it, the silence will break. Until then, the night sky is both mirror and mystery. We look outward and hear nothing. We look inward and hear the echo of our own fragility. And the question waits. Always waits. Imagine for a moment that the danger from the heavens is not an asteroid's impact, but something far subtler. Not fireballs, not craters, but seeds. Microscopic, invisible to telescopes, yet potent enough to alter the fate of worlds. This is the scenario some thinkers call the silent invasion. A possibility so speculative it borders on fiction, yet so haunting that it lingers in the mind long after the thought fades. What if the rocks that pass near Earth are not only natural wanderers, but vessels? What if within their icy cores lie microseeds, engineered particles, biological or technological, designed to awaken under the right conditions? The ancient hypothesis of panspermia. To understand this, we must begin with science. The idea that life can travel between worlds is not new. It is called panspermia. For more than a century, scientists have wondered whether comets and meteorites might carry microorganisms. Protected within rock or ice, some bacteria could, in theory, survive the cold of space, the radiation of stars, the passage of millennia. When fragments strike Earth, they might deliver these microbes, seeding life where none existed before. Some even speculate that Earth's own life began this way, that we are, in a sense, aliens, children of the stars. So the concept has roots in science, but the silent invasion takes it further. It suggests not accidental transfer, but deliberate design. Not microbes drifting by chance, but seeds engineered to wait, to observe, to activate. The power of patience. Consider the scale. A civilization millions of years ahead of us might not need fleets of ships to explore the galaxy. They might use time itself as their ally. Instead of traveling, they send seeds, small enough to hide in dust, durable enough to endure eons. They scatter them across the stars, hidden inside comets, asteroids, icy wanderers like 3Y/Atlas. The seeds wait. They cross interstellar voids silently. They drift through darkness, carried by gravity, tucked into natural orbits that seem random, but are not. And when they reach a star system rich in life, they awaken. No invasion fleets, no announcements, only a quiet release of influence, unnoticed until too late. Why seeds instead of ships? To us, the idea seems strange. Why not send ships, explorers, messengers? But ships demand energy, guidance, maintenance. Seeds demand nothing but patience. Ships can fail, crews can die, empires can collapse, but seeds persist. They are small enough to survive impacts, hidden enough to evade detection, countless enough to guarantee that at least some succeed. To plant seeds is to play a game of inevitability. Wait long enough, scatter wide enough, and eventually they take root. What might they be? Speculation here splits into two branches. 1. Biological seeds. Tiny organisms engineered to resist radiation, capable of surviving in dormancy for eons. When released into a new world, they adapt, evolve, perhaps even merge with native life. In this vision, alien biology could slowly alter ecosystems, shaping evolution without us realizing. 2. Technological seeds. Nanomachines, microscopic constructs, durable beyond any earthly device. They might lie dormant until they detect signals of intelligence, radio, industry, nuclear bursts. Then they awaken, gathering, assembling, sending information back, or preparing for purposes we cannot guess. Both visions are unsettling. Both blur the line between science and nightmare. The patterns of near misses. Think again of Earth's strange luck. Tunguska flattening a forest, Chelyabinsk shattering windows, Georgia 2025 tearing through a roof. Close calls, but not extinction. What if these events are not only accidents? What if they are controlled releases, designed demonstrations? The seeds do not need to strike cities to succeed. They only need to scatter. A fragment burning in the upper atmosphere could already be enough, releasing microscopic cargo invisible to our eyes. Impossible? Perhaps. But remember, many of Earth's great diseases began invisibly, with particles smaller than dust. The power to reshape a world does not always arrive with thunder. Sometimes it drifts down silently on the wind. The human blind spot. We are trained to look for danger in the obvious. Large asteroids, explosions, flashes in the sky. But our eyes are poor at seeing the small. Microscopic invaders could already exist in meteorite fragments collected on Earth, unnoticed among dust and rock. Even if we study them, how would we tell the difference between a natural microbe and an engineered one? Between cosmic dust and a nanomachine? Our instruments are powerful, yes, but only within the limits of what we expect to find. And if we are not expecting the seeds, would we even recognize them? The unsettling implication. If this scenario is true, even partly true, then humanity may not be untouched. We may already host traces of the seeds, buried in soil, drifting in air, encoded in DNA. The line between Earth-born and star-born might already be blurred beyond repair. What does that mean for who we are? For what we are? Are we children of Earth? Or children of the stars? Shaped by hands we cannot see? Awakening the seeds. If such seeds exist, then the question becomes, what would awaken them? Some imagine heat. As comets approach the sun, their icy shells vaporize, releasing dust into space. Hidden within that dust, seeds could scatter across orbits, carried on solar winds toward planets. Others imagine signals. Perhaps the seeds wait until they detect electromagnetic noise, evidence of technology. Radio waves, radar pulses, nuclear detonations. These are not natural. They are signs of intelligence, a perfect trigger for dormant watchers. In either case, The timing would feel precise. Seeds could remain asleep for billions of years, only to stir when conditions are right. The silence before activation would lull us into believing we are safe. A silent invasion. Unlike Hollywood's visions of warships and beams of light, this invasion would be almost invisible. No battles in orbit, no fleets descending. Only tiny awakenings, scattered across soil, water, air. Imagine waking tomorrow and learning that nanoscopic machines had been drifting in our atmosphere for decades, unnoticed, or that strands of DNA in our own cells contained fragments that could not have arisen on Earth. Would we believe, or would we dismiss the evidence as error, contamination, coincidence? The genius of such an invasion is its quietness. By the time you notice, it has already succeeded. Motives in the dark. Why would any intelligence design such seeds? The motives could be many. Exploration. Seeds gather data, send it back, building maps of life across the galaxy. Experimentation. Seeds alter ecosystems, testing how species adapt, recording results. Preparation. Seeds wait until intelligence rises, then influence its path, guiding, nudging, shaping. Conquest. Seeds dismantle, destabilize, replace. Not by force, but by patience. From the outside, we cannot know. The motives are as invisible as the seeds themselves. The filter within the seed. Now recall the great filter. If civilizations often destroy themselves, what better strategy than to seed others, letting them rise in your place? Perhaps the seeds are insurance, a way to spread survival beyond the failure of any single world. In this view, the seeds are not invasion, but continuity. They ensure that if one fire goes out, another will be lit elsewhere. That life continues, even if not as it once was. And so perhaps we are not targets. Perhaps we are the seeds already awakened. Perhaps humanity itself is proof that the system works. The weight of uncertainty. The unsettling truth is that we cannot prove or disprove this. Meteorites land on Earth every year carrying unknown materials. Some contain amino acids, precursors to life. Some contain organic compounds unlike those common on Earth. Each arrival could be natural or not. Scientists analyze, measure, categorize. But what if the most extraordinary evidence hides in the ordinary, too small to notice, too strange to recognize? How do you test for seeds that do not wish to be found? The quiet fear. As you lie in bed tonight, imagine looking up at the night sky. Every streak of light, every meteor shower could be a delivery. Each grain of dust could carry more than it seems. And ask yourself, would you want to know? Would you want proof that we are part of a silent experiment? Or is ignorance, comfort in thinking meteors are only stone and ice, better for sleep? Between wonder and dread, this is the edge where speculation becomes story, where fear and wonder intertwine. Perhaps comets are only comets. Perhaps seeds are only metaphors. Perhaps silence is only silence. But perhaps not. Perhaps tonight, as Earth spins beneath the stars, as meteors flash above the atmosphere, seeds drift quietly downward, too small to see, too patient to fear. And perhaps, in ways we cannot yet measure, the invasion has already begun. Imagine a moment when speculation ends. One day, astronomers track an interstellar object, like 1I/Oumuamua, 2I/Borisov, or 3I/Atlas, and they notice something unusual. It does not leave. Instead of slingshotting past the sun on a hyperbolic arc, it slows. It changes course. It chooses to remain. The discovery would shatter silence. The first realization. At first, scientists would hesitate. They would measure again, check their instruments, seek natural explanations. Could outgassing explain the motion? Could hidden jets of vapor mimic propulsion? But then the data would confirm no natural process could account for the trajectory. The object was acting with intention. The headlines would spread in hours. The world would awaken to a truth whispered in fiction for centuries. Something artificial has entered our solar system. The wave of reactions. Governments would meet in secrecy. Space agencies would release carefully worded statements. Markets would tremble. Ordinary people would turn their eyes to the sky, suddenly aware of how fragile our world feels when the unknown draws near. Some would rejoice, proof of life beyond Earth, confirmation that we are not alone. Others would panic, imagining invasion, conquest, endings. Still others would deny, dismiss, claim hoax or conspiracy. The range of human response would mirror our diversity: hope, fear, disbelief, wonder. Scientific frenzy. For astronomers, the object would become the most studied phenomenon in history. Telescopes across the globe, from Chile to Hawaii to space itself, would lock on. The James Webb Space Telescope, the Hubble, every radio dish and radar array, focused. What is its size? Its composition? Does it emit signals? Is it inert or alive or something between? Every scrap of data would be pored over, every anomaly dissected. For once, humanity's greatest scientific minds would share a single obsession: the question of ownership. But soon, disputes would rise. Who has the right to study it, to approach it, to decide humanity's response? Would it be NASA, the European Space Agency, China's CNSA, Russia's Roscosmos, private companies with rockets of their own? Or would the United Nations claim authority, arguing that contact with non-human intelligence transcends nations? The debate would rage. Behind closed doors, militaries would whisper about weapons, about threats, about secrets. Transparency might falter beneath the weight of fear. Public anxiety. Meanwhile, ordinary people would live under a new shadow. Some would gather in prayer, seeing prophecy fulfilled. Others would protest, fearing government lies. Conspiracy theories would flourish, some claiming the visitor was already here, others claiming it had been hidden for decades. The human mind seeks story, and in uncertainty, stories multiply. The sleeper's question. And as you drift toward rest tonight, imagine lying beneath that sky. Imagine knowing that somewhere above, a visitor waits, silent, patient, unmoving. Would you feel safer, knowing we are not alone? Or more fragile, knowing we are no longer unseen? This is the question humanity would face in its first true encounter. Not only what the visitor is, but what it reveals about us. Are we ready? First contact protocols. Though movies often show chaos, in reality, institutions have thought about this moment. The SETI post-detection protocols, drafted decades ago, outline how scientists should handle a signal or discovery. They emphasize verification, transparency, international cooperation. But protocols are fragile. They exist on paper, not in practice. When faced with a real object, silent, strange, and near, would nations truly share? Or would secrecy return, each power fearing what the others might learn? The visitor would test not only our science, but our trust. The military response. Inevitably, generals would ask, is it a threat? They would track its orbit, study its mass, estimate its energy. Could it move suddenly? Could it strike Earth? Could it release smaller probes? Weapons might be readied, not to fire, but to reassure. Satellites repositioned, defenses rehearsed. Yet in truth, our weapons would be powerless. If the visitor is advanced enough to cross stars, no missile or laser we wield could challenge it. The military would know this. But fear does not fade easily. The global conversation. Ordinary people would not remain silent. Social media would flood with speculation, images, theories. Every telescope hobbyist would post blurry pictures. Every influencer would claim insight. The visitor would become the most discussed subject in human history, overshadowing war, politics, even personal lives. And amid the noise, serious voices would ask deeper questions. Should we attempt communication? If so, in what language, what form? Who speaks for Earth? These questions would have no simple answers. The United Nations, a coalition of scientists, religious leaders, or no one at all, letting silence speak? The philosophical divide for philosophers and theologians, the implications would cut deep. Some would say the visitor proves humanity is not the pinnacle of creation. Others would argue it confirms old myths, angels, gods, watchers, now dressed in new clothes. And for many, the sight itself would be enough, proof that we are part of a larger story, proof that the universe is not indifferent. Possible scenarios. Speculation would swirl. Some imagine the visitor as a probe, automated, ancient, carrying knowledge or instructions. Others see it as a sentinel, placed here to observe until humanity reaches a threshold. Still, others fear it is a trap, a weapon, a patient strategy hidden in plain sight. The truth would remain silent. The visitor would not speak quickly, if at all. And silence can be more frightening than words. Humanity's reflection. In the end, the visitor's greatest effect might not be what it is, but what it makes us see in ourselves. Our divisions, our fears, our hopes, our hunger for meaning. Our fragility beneath the stars. If the visitor stayed, humanity would awaken to its smallness and its potential. For the first time, we would see ourselves not only as nations, but as a species. Not only as earthlings, but as part of a cosmic community, silent though it may be. The whisper before sleep. And so, as you lie in bed tonight, imagine it. Above us, silent, patient, a visitor drifts. It does not attack, it does not answer, it simply waits. Perhaps it is nothing more than stone and ice. Perhaps it is a messenger from a mind long gone. Perhaps it is a test, watching to see if we are ready. We do not know, and that is the truth that humbles us. The visitor remains, and we, fragile dreamers on a small blue world, must decide how to respond. When something unknown appears at the edge of human experience, our first instinct splits in two. One path urges us to reach, to study, to learn. The other whispers caution, warning us to step back, to shield ourselves from danger. These two instincts, curiosity and containment, have shaped every era of exploration. Now imagine them stretched across the stars. The pull of curiosity. From the moment early humans lit fires in caves, they gazed upward, wondering at the sparks in the night sky. Curiosity is the force that built telescopes, launched rockets, sent probes to the outer planets. It is why we chase comets, land on asteroids, sample Martian soil. To ignore the unknown is to ignore ourselves. If an object drifts through our solar system, be it rock, probe, or seed, the pull of curiosity demands we reach out, to measure, to sample, to ask. Scientists would argue, every fragment of data matters. Every sample could unlock cosmic history. To let a visitor pass unstudied would be a loss beyond words. The voice of containment. And yet history teaches caution. Ships that sailed across oceans carried not only explorers but diseases. Contact between worlds on Earth often ended in devastation for those unprepared. Curiosity without caution can kill. Containment whispers, do not touch, do not open the box, do not welcome what you cannot understand. The object may carry dangers invisible, pathogens, nanomachines, signals meant to deceive. To approach blindly would be folly. The debate on Earth. If a strange visitor remained in orbit, the debate would ignite across governments and communities. Some would argue for missions, rockets to intercept, robots to study. Others would argue for distance, watch, but do not touch. Still others would demand secrecy, fearing public panic if the truth were fully revealed. The tension would be sharp, discovery versus survival, progress versus caution. Lessons from history. Look back to the Apollo missions. When astronauts returned from the moon, NASA quarantined them for weeks, not because they expected alien microbes, but because they could not be sure. Even lunar dust was treated as potential threat. Consider also the handling of meteorites. Some contain amino acids, precursors of life. Scientists debate whether they formed naturally or hint at cosmic biology. In every case, caution guides the hand. So if a true visitor arrived, one with unknown origin, the lessons of history would weigh heavily. The sleeper's question. And as you prepare to drift into rest tonight, imagine this. Above us, an object circles. Within it, perhaps secrets, perhaps dangers. Should we reach for it, risking everything for knowledge? Or should we seal it off, letting mystery remain mystery? Which instinct would you trust? Which instinct would let you sleep? The weight of decision. Imagine the meeting rooms where such choices would be made. Long tables, sharp suits, screens glowing with orbital data, scientists pleading for access, generals warning of risk, politicians balancing fear and hope. The arguments would circle endlessly. If we approach, we might learn everything. If we approach, we might unleash disaster. If we avoid, we lose knowledge. If we avoid, we preserve safety. There would be no perfect answer, only imperfect choices. Humanity's future could pivot on a single decision, to reach or to retreat. Curiosity's temptation. The lure of discovery is strong. Every civilization that has endured has done so by pushing boundaries. To stand still is to stagnate. Scientists would argue, if we never risk, we never grow. Imagine intercepting the object, drilling into its surface, uncovering alloys unknown, patterns too precise for nature. Imagine signals embedded in its dust, instructions waiting for us to decode. A treasure chest of cosmic history drifting above, daring us to open it. Could humanity resist? Containment's warning. And yet, restraint has its wisdom. What if the object is a Trojan horse designed to be opened? What if the seeds it carries awaken not in ice, but in laboratories? Containment reminds us, Earth's biosphere is fragile. One mistake could mean extinction, not discovery. To poke blindly at the unknown is to gamble with all life. Some would argue for extreme caution, isolate. Observe from a distance, never attempt contact. Better ignorance than annihilation. The middle path. Perhaps the truest course lies between. Remote study first. Robotic probes sterilized, tested, monitored. Layers of caution, checks at every step. If danger lurks, let machines face it before humans, and even then, transparency would matter. Secrets breed fear. If humanity is to face the unknown, it must face it together. A mirror to ourselves. In truth, the object's greatest gift may not be its secrets, but the reflection it casts on us. Do we value knowledge more than safety? Do we trust curiosity more than fear? Or will fear choke discovery before it begins? Every choice reveals what kind of species we are becoming.
bold or cautious, united or divided, explorers or prisoners of our own anxiety, the whisper before sleep. So tonight, as you drift toward dreams, imagine Earth beneath a silent guardian. It waits, patient, circling, carrying mysteries we cannot yet name. Would you send a ship to meet it? Would you lock it away, untouched? Or would you wait, hoping time itself reveals the truth? In the end, the stars ask questions as much as they give answers. Containment or curiosity, safety or knowledge, fear or wonder. The choice is ours. And in that choice lies the story of humanity itself. The stories we have followed, the asteroids that pass by, the whispers of the dark forest, the shadows of the great filter, the silence asked by Fermi, the fears of microseeds, are not just curiosities. Together they form a mirror, a reflection of who we are and what we fear and how we hope. Each mystery leaves behind a lesson, though it may not be written in words. To understand, we must gather the fragments. Lesson 1. The fragility of Earth. Every close call with a meteor, every crater on the moon, every scar in Siberia or Arizona reminds us, Earth is not invincible. Our planet is a small, vulnerable rock, spinning in a cosmic shooting gallery. The first lesson, then, is humility. We are not masters of the universe. We are passengers. Our survival depends on forces beyond our control: gravity, chance, time. To forget this is to live in illusion. Lesson 2. The power of protection. Yet fragility does not mean helplessness. Jupiter with its massive gravity pulls many threats away. Saturn, too, has shaped the paths of countless objects. Our solar system itself offers shields, silent and unseen. From this we learn a second lesson. Sometimes survival comes not from strength, but from guardianship. We are here not only because of ourselves, but because of forces we did not command. Protection may arrive in ways we never notice, until we look back and see how many times we might have fallen, but did not. Lesson 3. The silence of the sky. Fermi's whisper, "Where is everybody?" reminds us that silence can be as loud as noise. The absence of signals forces us to ask if survival itself is rare. This is a lesson in perspective. The universe may not be filled with neighbors ready to greet us. It may be vast, indifferent, even empty of voices like ours. We must accept that we could be early or alone or watched. Each possibility shapes how we see ourselves. Lesson 4. The shadows of fear. The dark forest hypothesis warns that danger might hide in silence. The great filter warns that destruction might wait ahead. Microseeds warn that invasions might arrive quietly, not with fire, but with patience. These are lessons about fear, how it shapes us, how it guides us. Fear is not weakness. It is survival's companion. But unchecked fear can paralyze, closing doors that curiosity might open. The lesson is balance. Fear enough to protect, courage enough to explore. Lesson 5. The choice within us. Containment or curiosity. To reach or to retreat. To open or to close. Every mystery circles back to choice. The universe presents the unknown, but humanity decides how to respond. And here lies the deepest lesson. The unknown is not only out there, in comets and stars, it is within us. The way we answer reveals what kind of beings we are becoming. A whisper for the sleeper. So tonight, as you rest, remember these fragments: fragility, guardianship, silence, fear, choice. The unknown is not a riddle to be solved in one night. It is a companion, walking beside us through history. And every time we look upward, we meet its eyes again. Lesson 6. Time as teacher. The universe moves on scales far beyond our lives. Stars burn for billions of years.
Civilizations, if they arise, may flicker for only thousands. Against this scale, humanity is still in its infancy. The lesson is patience. We cannot demand answers in a single lifetime. The silence we hear today may not last forever. The visitors we long for may not arrive tomorrow, but in centuries, millennia. Our task is to prepare, to endure, so that when the moment comes, we are still here to witness it. Lesson 7. Unity in smallness. The threats from the sky, asteroids, comets, unknown forces, do not respect borders. They do not care about politics, language, or wealth. If disaster comes, it comes for all. Here lies another lesson. Survival requires unity. Humanity must learn to act as one, not as fragments. To see ourselves not only as nations, but as a species. Not only as earthlings, but as voices in a cosmic silence. Lesson 8. Wonder as fuel. Curiosity is not weakness. It is the fire that carried us from caves to continents, from continents to the moon. Without wonder, there is no growth. Without risk, there is no progress. The lesson is clear. Fear protects, but wonder propels. To balance the two is to survive and to flourish. Lesson 9. Mystery endures. Perhaps the most humbling lesson is this. The universe does not owe us answers. Some mysteries will remain unsolved not because they hide from us, but because we are not yet ready to understand. And that is all right. The unknown is not our enemy. It is the horizon that keeps us moving forward. The final whisper. As you close your eyes tonight, remember, every shooting star above is a reminder. Each flash of light across the sky is both warning and gift. The unknown does not ask us to conquer it, only to listen, to learn, and to endure. We are fragile. We are curious. We are afraid. We are united, and we are still here. That, in itself, is extraordinary. Call to action for the listener. If these whispers of the cosmos stir something in you, hold on to it. Do not let the silence frighten you into inaction. Let it remind you that we are part of something vast, mysterious, and unfinished. Look at the night sky when you can. Share these questions with others. Keep curiosity alive. And if you feel the weight of the unknown pressing on you, remember, it is not a burden, but an invitation. The universe waits, quietly. The question is whether humanity will be ready when the next mystery arrives. And so I ask you, not as a scientist, not as a storyteller, but as a fellow traveler beneath the stars. Will you choose fear, or will you choose wonder? If this journey through the mystery of the cosmos kept you awake in thought, or gently carried you towards sleep, I invite you to stay with us for more. Leave a comment below. What do you think truly saved Earth from the falling stones of space? Was it pure science, or something beyond our understanding? Don't forget to like this video, subscribe to the channel, and tap the bell icon so you'll never miss the next story under the stars. Every click helps us bring more mysteries of the universe right to your ears, night after night. Good night, dream well, and keep looking up.